This will be for the con exercise, distance between point and line. So if I can sum it up into one sentence, the distance from a point to a line is the length of the perpendicular segment connecting the two. So they want us to find the minimum distance between the point 2, -1 and the line x equals -3. So in the case of a horizontal or vertical line, it's much easier. All right, so really you can just count in this case. All right, since this line is x equals -3, the perpendicular line will be a horizontal line. Okay, here's the point, and going to the line, it's right there. Okay, and of course it's got to be perpendicular. It makes the right angle. And we just went from 2 to -3. So if you did the absolute value of 2 minus -3, that is just 5. Okay, the two negatives make it positive, and that's just 5. So nothing to calculate there, really. You can even just count the units. If you go from this point, 1, 2, 3, 4, 5. Okay, so if it's a horizontal or vertical line, it's very easy. If it's so far that you can't count, if the distance is so great that you can't count, just subtract the absolute value of the x-coordinate of the point and the x-coordinate of the line. Okay, and if it's originally a horizontal line and you have to draw a vertical line, then you're just going to do the y-coordinates. So this answer here is just 5. Okay, they want us to find the minimum distance between the point -6, -5 and the line y equals -3x minus 3. So basically, we're going to have to find the length of the segment that goes to this line and is perpendicular to the line. All right, so we're going to have to do a little bit of algebra for that. So this right here, this line equation is in the form of y equals mx plus b. So clearly we can see the slope is -3. And we need to take the negative reciprocal of that. All right, so keep that -3, take that -3, and there's 2 steps for negative reciprocal. You want to flip it. So if it helps, you can just put this over 1. Okay, you want to flip it or take the reciprocal, so that's -1/3. And then change the plus-minus sign, so that's going to be +1/3. And this right here is the new slope, or the new m. So we need to write an equation for the segment that connects the two, okay, that little line segment. All right, so I'll use point slope form at first and then just distribute. So that's going to be y minus y1 equals m times x minus x1. Okay, this point is going to meet the segment. The segment's going to pass through this point, so we can call this x1 and y1. Okay, so y minus y1 is going to be y minus -5. The new slope m is +1/3. And that's times x minus x1 is going to be x minus -6. Okay, 2 negatives in a row make it positive. And these 2 negatives make it positive as well. We want to solve for y because we're going to have to set it equal to this. Okay, so the opposite of y plus 5 is -5. And let me erase this on the bottom. I need more room. All right, so let's see. We subtracted 5 on both sides. 5 minus 5 cancels. And I'm going to distribute the 1/3. 1/3 times x. And 1/3 times 6 is 6/3, but 6 over 3 is just 2. And we still have minus 5. So that's going to be y equals 1/3 x minus 3. So this is the equation of the segment that connects the point and the line. And this is the equation of the original line. Okay, so if we want to see where these two lines intersect, we want to set them equal to each other. So we're basically going to be doing y equals y. All right, let me erase some of this. So to find out the other point where they meet, I'm going to set y equal to y, but we can't solve that. So this is y right here, negative 3x minus 3. And this is y right here, 1/3 x minus 3. Okay, so adding 3 to both sides. The 3's actually cancel on both sides. And negative 3x equals 1/3 x. And I can tell already this is going to be 0. Okay, if you want to make sure you can convert this to thirds, so that's negative 9/3 x equals 1/3 x. And then if you do minus 1/3 x on both sides, actually I'll do plus 9/3 x on both sides. Okay, and that's going to be 10/3 x equals 0. Okay, I just added 9/3 to both sides right here. 9/3 plus 1/3 is 10/3 x, and this one cancels. So you can see x is clearly just 0. All right, and if you plug in x equals 0 in either equation, let's say I put a 0 there, y is going to be negative 3. All right, so the first point is negative 6, negative 5. And the second point is 0, negative 3. So we need to find the distance between those 2 points. All right, so if you go to 0, negative 3, that's this point right here, you can use distance formula, or you can just use Pythagorean theorem. Okay, so I'm going to construct a right triangle. This is 2 units up. We don't have to worry about positive or negative for Pythagorean theorem. And then I'm going to go 1, 2, 3, 4, 5, 6 units to the right. And the distance we are looking for is the hypotenuse, which is this distance right here. Okay, so this is going to be a right triangle that I just constructed. The side across from the right angle, that's always going to be C. So if we do a squared plus b squared equals c squared, a and b, it doesn't matter which is which. So I can let a equal 2 and b equal 6. So that's going to be 2 squared plus 6 squared equals c squared. Okay, 2 squared is 4. 6 squared is 36, and that equals c squared. And of course, 4 plus 36 is 40. That equals c squared. And solving for c, you just take the square root of both sides. Okay, the square root of c squared is just c. They said leave your answer as a radical. So I am just going to leave it as radical 40. So that is the distance from the point to the line. Again, you can use distance formula if you want, but Pythagorean theorem might be a little bit easier. So just click in the box and type the square root of 40. Now you might get an easy one where you don't have to go through that entire process. Okay, so for instance, this one here, we can kind of see that the segment from the point to the line would just be this segment right here. Okay, but you don't want to just say, well, that's just one, because that might not be true. All right, if you take the y distance, that's a 1, and you take the x distance, that's a 1. And if you make a right triangle here and call the hypotenuse c, you're going to do a squared plus b squared equals c squared. Okay, a and b, it doesn't matter which is which. So that's going to be 1 squared plus 1 squared equals c squared. Okay, we know 1 squared and 1 squared. 1 squared is just 1, and 1 plus 1 is 2. That's going to be c squared, taking the square root of both sides at the very end. Square root of c squared is just c, and that's radical 2. Okay, so don't just try to count diagonally and say, well, that's just 1 unit. That's not 1 unit, okay? That's radical 2 units. So in the box, you're going to have to do the square root of 2, radical 2. You click on that symbol.